Hi Nat, 5, so 4 questions today for the starter. I want you to pause the video, I want you to complete all 4 questions, unpause it, and then you can self-mark with the answers I'm about to give you. So, question 1, calculate the mass when you have 0.4 moles of ethanol. Okay, so we know our moles, so we can do our wee sidebar, moles, mass, and our GFM. Okay, now our equation is N equals mass over GFM, but we're not after the number of moles, we're after the mass. So we need to rearrange it, so it's mass equals moles times GFM. Okay, so we don't know the mass, we know the moles is 0.4, and the GFM we would need to work out here, so we have 6 hydrogen, hydrogen's 1, so that's 6. Oxygen, if you use your data book, is 16. Carbon's 12. We've got 2 of them, so that's 24. And if we add all that up, that is going to give us 46. Okay? Right. And the GFM is 46, so that is 0.4 times 46. And if we do that in our calculators, that's 0.4 times 46, and that is giving us 18.4 grams. Okay? Right, question 2. 0.75 moles of citric acid was dissolved in 250 centimetre cubed of water. Calculate the concentration of the solution formed. Now, we've not been given a mass this time, or we're not asked to work out the mass. We're asked to work out the concentration. Okay, so our normal equation would be N equals CV. Okay, so we do our sidebar. Tells us we've got 0.75 moles. Yeah, we don't know what the concentration is, so that's what it's asked us to calculate, and we know our volume's 250 centimetre cubed. Now, we don't just put 250, remember, we want to get that into litres, and how do we get it into litres? We divide by 1,000, so what we would have here is if we do 250 divide by 1,000, we get 0.25 litres. Okay, now concentration, N equals CV, but we want the concentration, so bring the V down, so that's N over V, sub in our values, 0.75 divided by 0.25, and that is going to give you a concentration of 3, and remember the units for concentration, it's mole per litre. Okay, make sure you know that, make sure you're comfortable with that. Right. Question 3, which one dissolves in water to form an acidic solution? Now, because it's an acidic solution, we are looking for a non-metal oxide, and you should know that, okay? Now, that rules out C, because that's a metal, it rules out D, that's also a metal. So it's either A or B. Now, it can't be A, because silicon dioxide, you should know this, it's a covalent network, it's insoluble. Okay, so it can't dissolve, so nothing's going to happen to the pH of water if we add silicon dioxide. So our answer is B. And sulfur dioxide, that's one of the acid rain gases. Yeah, one of the gases that contributes to acid rain along with carbon dioxide. Okay, right, question 4. A white solid X is soluble in water, so that's important. It's soluble in water. It can also react with hydrochloric acid to produce carbon dioxide. Now, it's reacting with HCl, which is an acid, so it's a base. Yeah. Now, A, B, C, and D are all bases, so that's a metal oxide, metal carbonate, metal carbonate. They're all bases. Okay. Now, it produces carbon dioxide, okay? So that should rule out A, and it should rule out B, because carbon dioxide only forms when you've got a carbonate, remember, okay? That's important, a carbonate. So, it's either C or D. Now, it does say it's soluble, So you would need to go to your data booklet, okay? And we're looking for, what's that? Copper 2 carbonate. So copper 2 carbonate is insoluble, so it can't be that. Which must mean the answer is D, potassium carbonate. But let's just check. Potassium carbonate is very soluble, so that's our answer, okay? Right. So, our lesson today is mole calculations, lesson 7. So we're going to carry on with our mole calculations, okay? So, I want you to put the subheading, combining both mole equations. Yeah, so make a wee note. So both N equals M over GFM and N equals CV can be used to work out an unknown. Okay, and the best way to do this is to literally just go over it. Okay, so that's what we're going to do. So I'm going to give you a couple of questions, and then we'll start going over it. So first question, I want you to calculate the mass of chemical present in each of the following solutions. Okay, and you'll see what I mean when we start going through this. So that's the question. We're going to do 3, okay, so A, B and C, and then we'll change it up ever so slightly, and then that'll be us. So 25 centimetre cubed of a 1.0 mole per litre solution of HCl. Yeah, hydrochloric acid. So, what we're trying to do, we're trying to work out the mass. Yeah, we've been given the volume, and we've also been given a concentration. Yeah, moles per litre, that's our units of concentration. So what we can do is we can split our page into 2, okay, and we can put the 2 equations here, N equals CV and N equals M over GFM. Okay, now with a question like this, you'll always be able to do at least one of these. Okay, now if you look at that, we're trying to calculate the mass, so we obviously can't use that. Yeah, which must mean we must be able to use CV, and we can because we've been given a concentration and we've been given a volume. Okay, so N equals 1, yeah, times 25. Now remember, okay, if I just do the wee sidebar here, concentration is 1, we've got to divide by 1,000 there, so that would be 0.025. Okay, so that's going to be 1 times 0.025, and that just gives us 0.025 moles. Okay, now what we can do, we can transfer that in. Okay, now we're trying to work out the mass. Okay, that's what we're trying to work out, so we have to rearrange this equation. So M equals N times GFM. Okay, so the number of moles we've got from here, so 0.025, 0.025, and the GFM we can get from up here. Okay, so the GFM of hydrogen is 1, and chlorine, it is in your data booklet, okay? So if you turn to page 7, chlorine is 35.5. That's the GFM of chlorine. 35.5, add that together, you're getting 36.5. So you would do 0.025 times 36.5, and if you do that on your calculators, what's that? 0.025 times 36.5. That's your answer there, 0.9125 grams. Okay, that's it. That's how you do that. So I'll do another 2, and then we'll change it ever so slightly, and then you guys can start to do your own questions. Right, let's go for 50. So again, we're still calculating the mass, yeah, of the following solution. So the solution is 50 centimetre cubed of 0.5 mole per litre solution of sodium hydroxide. Okay, so again, we're trying to work out the mass, and what we're given is the volume, and we're given the concentration. Okay, so like what we normally do, we split our page into 2, and we can put our 2 equations up here, N equals CV and N equals M over GFM, and we need to decide what one we want to use. We're working out the mass, yeah, so we can't find out the number of moles because we don't have a mass, but we are given a concentration, we are given a volume, so we can use this one. Okay, so got a wee sidebar here. Number of moles we don't know, the concentration is 0.5, and the volume is 50, but remember, you need to divide by 1,000. So 50 divided by 1,000 is 0.05. Okay, so that is 0.5 times 0.05. And again, if we do that in our calculator, 0.5 times 0.05, we're getting 0.025 moles. Okay, now that we've worked out the moles, remember that can transfer over. Okay, we're trying to work out our mass, so that's M equals N times GFM. Okay, so the number of moles is 0.025, and we get that from that side, yeah. And we're trying to work out the GFM of sodium hydroxide. So hydrogen's 1, oxygen's 16, and sodium's 23. I'll just show you. Sodium, where is it? There it is, 23. Okay. And if we add all of that up, we get 40. So 0.025 times 40, and 0.025 times 40, we are getting 1. Yeah? 1 gram. And that's it. Okay? Now, what I want you to do, I want you to write this one, and I want you to try it on your own. Okay, so 250 centimetre cubed of 0.25 mole per litre solution of sulfuric acid, and again you should know sulfuric acid is H2SO4. Okay, so we're trying to work out the mass. So we've been given a volume, we've been given a concentration. Okay, so split our page into 2 and put our 2 headings, our 2 mole equations, N equals CV and N equals M over GFM. Okay, we're trying to work out the mass, so again, we can't use that one. So, pause the video. I want you to attempt this question yourself. unpause it, and then I'm just about to go over it, okay? So we can't use that equation, as I said, but we can use C times V, okay? We don't know the moles, the concentration is 0.25, and the volume, because it's in centimetre cubed, we need to get it into litres, divide by 1,000, that is 0.25. So, number of moles is 0.25 times 0.25. And if we do that in our calculators, 0.25 times 0.25, we are getting 0.0625 moles. Okay? Transfer that across. Rearrange this equation to work out the mass. That's N times GFM. So that's 0.0625, and the GFM, yeah, of H2SO4, I'll run out of space, I'll do my work in here, H2SO4, so oxygen is 16, 16 times 4 is 64, sulphur is 32, I'll just show you that on the data booklet, sulphur, 32, okay, and hydrogen is 2, so if we add that up, 64 add 32 is 96, add 2, 98. So sub that in, and our answer, yeah, 0.0625 times 98, and we're getting 6.125 grams. Okay, right. Next question, question 2. We'll call this. It can work the other way, okay? You can be asked to be given to work out the mass, but you could also be asked to work out the concentration or maybe even the volume, okay? However, what I'm going to do is we're going to calculate the concentration. So I would like you to calculate the concentration in moles per litre, obviously. Yeah, that's the units of each of the following. Okay, and again, we'll do 3 of these, and then that will be us for this video. So the first one, I'd like you to do 3.65 grams of HCl in a 1 litre solution. Okay? Now, like what we have been doing, we split our page into 2. Okay? Now, this time we've been asked to work out the concentration. We've been given, hopefully you can see, that's a mass, yeah? And we've been given a volume as well. Okay? So, what we do, put our 2 headings, N equals CV, N equals M over GFM. Now, one of these we can use, okay? Now, we can't use this one, N equals CV. We do have a volume, you're absolutely right, we do have a volume, but we don't have a concentration, so we can't use this equation, which means we must be able to use that. Now, we've got a mass, excellent, and obviously we can work out the GFM. So, absolutely perfect, we can use this one. So, mass over GFM, so our mass is 3.65, okay, and our GFM, we've already done this, chlorine is 35.5, hydrogen is 1, so that's 36.5, so 3.65 divided by 36.5, now that should be 0.1, but let's just obviously always check. 0.1, okay, so that's 0.1 moles. Now, what we can do, yeah, we can move the moles over to this side, yeah? Now, we're after the concentration, so we have to rearrange this equation here. So, C equals N, bring the V down, divided by V. The moles, nice and easy, we've worked out. is 0.1. And the volume is 1. We don't need to divide by 1,000 because it's already in litres. Okay, so that's 0.1 divided by 1, and our answer is 0.1 moles per litre. And guys, that is it. Okay, these types of questions, they don't get much harder than this. Okay, right, let's keep going. Next one, we're going to do 2 more. So B. Let's go for 6.62 grams of PB NO3 2 in 250 centimetre cubed solution. Okay, so again, we've been given a mass, we've been given a volume, but what we want to do is work out the concentration. Okay, so as usual, split your page into 2. Put your 2 headings, N equals CV, N equals M over GFM. Okay, now what one can we use? We can't use that because we've got a volume, but we don't have a concentration. So we must be using that. Now, anytime you're given a mass, anytime, you can work out the number of moles because we can always use the data book to find the GFM. So the mass is 6.62 and the GFM is quite a difficult one to work out, but we'll do it together. Okay, so oxygen, there's 3 oxygens, but it's multiplied by 2, so we've got 6 oxygens. So that's 6 times 16, that is 96. Yeah, nitrogen, we've got 1 of them, but it's in a bracket with a 2, so we've got 2 nitrogens, and nitrogen is 14. Okay, there it's there, 14. So that would be 2 times 14, which is 28, and then PB, which is lead. Lead PB is 207. Okay, 207. So if we add this up, 96 add 28 add 207, we have 331. Yeah, makes for a nice number. So 6.62 divided by 331, 0.02. Okay? Moles. So we can transfer that over, remember? And we're trying to work out the concentration, so we need to rearrange the equation, bring the V down, N over V. So the number of moles we've worked out is 0.02. And our volume is 250, but it's in centimetre cubed. What do we want it in? We want it in litres, so we divide it by 1,000 and we're going to get 0.25 for that. Yeah, if you can't do it in your head, you use a calculator, okay? So 250 divided by 1,000, just to show you, obviously, 250 divided by 1,000 is 0.25. Okay, so if we do 0.02 divided by 0.25, 0.08 is our answer. Okay? Right, last one, and I want you to do this. Let's go for 1.58 grams of KMnO4. Okay, so that's potassium, manganese, and oxygen. 3 elements in. Let's change it a wee bit. In 150 centimetre cubed solution. Okay, so I would like you to pause and I would like you to work out what the concentration is. Okay? Right, hopefully you've worked that out. So again, what you should have done is split your page into two. Get your two headings. And know that we can't use that because we don't have a concentration, but we can use this one because we've got a mass. Yeah? And we can work out the GFM. So the mass is 1.58 and the GFM, yeah, KMnO4, oxygen's 16, times that by 4, you're going to get 64. Manganese, yeah, where is it? Up here. Mn is 55, okay, 55, and potassium, K, where's that, is 39, okay. So what we do is we add this up, 64, add 55, add 39 is 158. Okay. And again, nice good number. This should hopefully be 0.01, but let's just check, obviously. 0.01 moles. Okay, that's the first part done. Transfer that over, okay, and we need to rearrange to work out the concentration. So C equals N over V. We know the moles because we've worked it out on the other side, so that's 0.01, and our volume is 150 centimetre cubed, but we want that in litres, okay, so that is 0.15, yeah, so 0.01 divided by 0.15, and we are getting 0.06666666, but I'm going to round up. You can't just leave it like that. If you have it like that, you'd lose a mark. You've got to round up, so you need to get a 7 there. Okay, so that's mole per litre as well. And that's it, guys, okay? So you need to know how to work out the mass when you're given a concentration and volume. You also need to know how to work out the concentration when you're given a mass and volume. And you could also, I've not asked it here, but you could also be asked to work out the volume and you've been given a mass and a concentration. It would be the same thing. You work out the number of moles, and then instead of using C equals N over V, you would use V equals N over C. Okay, it's the same thing. So that's that lesson there. I want to leave it there and I'll put up some questions on Teams for you. Okay? Right, thank you.